Welcome everyone. In this video we are going to solve differential equations in Simulink, in MATLAB Simulink. So I have this differential equation which is y double prime minus 6y prime pi plus 5y is equal to 0, and we have these initial conditions. So first thing I will do is that the highest power derivative will be left on the left side, and we will separate it like this with the other derivatives on the right side. So we will always rearrange the equation with the highest power derivative on the left side and the other equation on the right side. So I can solve this equation by converting into the algebraic equation. For example, converting into the Laplace transform. So this equation is going to give me s square plus 6s minus 6s minus 6s plus 5 is equal to 0. This is minus, not plus. This is minus. So I can solve it like s square minus, I can factorize it, s square minus 5 s minus s plus 5 is equal to 0. Plus 5 is equal to 0. So again I can take the s common, we will have s minus 5, and then minus 1 common, we will again have s minus 5. So we will have s minus 5 and s minus 1 is equal to 0 from here. S minus 5 and s minus 1 is equal to 0. So we have roots which are 5 and 1. 5 and roots are my solutions to this equation, which are real and different. So the solution to this equation will be y of x is equal to c1 e power x plus c2 e power 5x. So this will be my solution to this differential equation. If you remember your concepts, if you remember in differential equation, for the roots which were different and real, we have this type of solution. So we have 1 and 5, so we have c1 e power x plus c2 e power x. Now if we use the initial condition of y is equal to 0 and y prime of 0 is equal to 1, we will have c1 is equal to minus 4, c1 is equal to minus 4, and c2 is equal to 1 by 4. So we can put in this c1 and c2, and then that will be my solution to this differential equation. So now I will go to the Simulink and I will try and perform this in my Simulink. So I will go to the MATLAB. Again I can open Simulink by typing this Simulink or typing new blank model. I will select because I am creating a new model. So there is my Simulink model. Because we have a second order differential equation, so I need two integrators. One of the nicest way to bring blocks into the Simulink environment is by left clicking on the canvas and typing that block name. For example, when I left click it and I type in the integrator name, this integration appears. Again I am going to initial condition for this. Let us not give it initial condition now. Again I will left click it and type integrator is going to appear. So we had two integrators. Why? Because we were having a second order differential equation. Simply I need a summer. We have a summer here, and what else do we need? We need a gain as well. So here we go, we have a gain as well. So probably we want two gains. Now what I will do is I will place it here. I will connect those two here. Fine. I will put the summer here. Now what I will do is that let me put the summer here. So I can label here. I will label this as y prime. Fine, this is my y prime, and this is my, let me connect it to some, I also need a scope, so I will left click and type in the scope and bring it the scope here. So I will connect the scope temporary to this, then I can delete, and I will type in here y. So this is my y in this equation. So this, if there is my second order derivative, after taking the integration I will get y prime, which is the second, which is the first order derivative. Then again after taking integration I get where, which is the simple y. Fine. Now if we look at this equation, we have y double prime is equal to 6y prime minus 5y. So 6 gain of 6 must be multiplied with y prime, gain of minus 5 must be multiplied with a y. So what I will do, I can simply rotate it by pressing Ctrl R. Ctrl R is going to rotate it. Fine. Then with y we had what? We had minus 5 with y, and with y prime we had 6. So I will replace this with minus 5, because with I will apply here, and so what I will do that by right clicking we will branch out here. Fine. And I am going to connect this to this summer, and then we have this another one. So the y prime was connected with 6, so I can simply bring the block over here into, I will again, for branch out I need to click the right click. The right click, I need to give the value of 6 here because it was 6y in my equation. I will apply it, and then I will add it to this summer. So this is my minus 5y and this is my 6y prime, and this both will be integrated given to this. Fine. And then we have the scope here. So I think we are good to go. Let me check it again. We have 6y prime minus 5y. So we have a 6y prime minus 5y, and those both are added, and we have a double integration. So what we will do is that we will run it. It's running, and now we have run it. So let me check the output of this signal. So we are not getting the output because we haven't given the initial values, and from the initial values we can see that y of 0 is 0, y prime of 0 is 1. Fine. So y prime of 0 was 1, and this was my y prime. This initial value is 1, and this initial value has to be 0. Okay, so we will run it again and we will see the output. So here we go, we have this output, which is the solution, which is actually minus 1 by 4 e power x plus 1 by 4 e power 5x. So this is my minus 1 by 4 e power x and 1 by 4 e power x. Fine. I can also confirm it in MATLAB. For example, we saw here that our solution was this, which was minus 4 e power x plus 1 by 4 e power 5x. This was my solution. So I will plot this solution in MATLAB, and then I will check whether I get the same graph as this graph or not. So remember this graph, that it was extending towards something. This is power 20. This is something like 12 or 14 power 20 at t is equal to 10. At t is equal to 10, it is something approaching towards not 14 power 20 but 15 or 13 power 30. By the way, we'll not close this program, so that we'll go to the MATLAB and we will open the editor by clicking edit. I should drag it to the right side so that it's more clear to you. So first I will define t, because t was defined from 0 to 10, so I will also define it from 0 to 10. My equation was that, for example, x is equal to minus 1 by 4, which is minus 0.25 multiplied by exponential of t. Fine. Plus 0.25 multiplied by exponential of 5t. So now I have written this equation in MATLAB, and I will go on and plot it to check whether I got the solution right or not. So I will plot. On x-axis we have t, on y-axis we have y, which is x. So let me run it and let me check the plot. So there is my plot. As you can see that the values are same. So this is also approaching towards some 13 power 20, and this thing in the MATLAB Simulink in the scope, this was also approaching towards 2 power 20, which means that we got the same graph for both two equation, which confirms that this solution to this equation is been plotted in MATLAB Simulink. So that's how we find solution to differential equations in MATLAB. If we have a third order equation, we can have three integrators and so on. So this was my model. This was my Simulink model. If you want to increase its size, I can simply press Control plus plus. Control plus plus is going to increase its size. It will going to zoom in. So that's it. We have this equation, which is was this thing, y double prime minus 6y prime plus 5y, and this solution was minus 1 by 4 e power x plus 1 by 4 e power 5x, and we have plotted this solution in Simulink, as well as we have plotted this solution in MATLAB programming, and we have verified that both our solutions are correct. So that's all. Thank you.